In our next section, we're going to look at the virtual firewall feature, or the security context feature of the ASA, which allows us to virtualize a physical box into multiple logical firewalls that we can then define different inspection policies on. Now, as I mentioned briefly before, one of the differences between ASA version 9 and the previous ones before it was that the multiple context mode had a bunch of limitations in terms of both routing, VPN, and also the inspection mode of the firewall, whether we are running in transparent or routed firewall. So we're going to look at this feature first on version 8.6, and then we're going to look at it a little bit later on version 9 and compare and contrast what are some of the advantages feature-wise of the new particular versions. Now, essentially what this feature allows us to do is to take one physical box and virtualize it either with our physical interfaces or with different sub-interfaces, so that we have multiple either sections for administration if we're offering managed services. If we want to say one department has one firewall that they manage, a different department has a different firewall that they manage, or we can use this for separating things like VPN termination versus regular firewall filtering. Now, in our previous example, we were looking at using just two interfaces where we had the inside and we had the outside interface. And we looked at that both in the routed mode, which is the default, and we looked at it in transparent mode, in which case we were bridging traffic at layer 2. Now, in this case, we're going to be looking at it with multiple contexts, where router 1 and router 3 are going to be in different contexts. We're going to call this simply context 1 and context 2, which is then going to allow us to configure different filtering policies, different inspection policies for traffic that is going from router 1 to 2 versus for traffic that is going from router 3 to 2. Now, the first portion of this from a configuration point of view is to, if we look back at the ASA CLI here, is to look at the show mode. Now, the other command that we looked at before was the show firewall, which tells us whether we are bridging traffic in transparent or whether we are routing traffic in routed mode. Now, we can basically have any combination of the four of these options, where we were doing routed mode in single context, we were doing transparent mode in single context, then we also have the option to do routed mode or transparent mode in multiple context, and then, like I mentioned, in version 9 we could do a combination of both of those at the same time. But in any case, in order to start the feature from global config, we're going to say that the mode is multiple context. Now, when we change from single context to multiple context, notice it's going to it mentions here this is going to change the behavior of the box, and it does require a reboot in order to do it. Now, we'll see when it actually does the change from single to multiple context, it is going to try to save the config that you have in there, and it's going to keep a copy of it in Flash so you can reference it if you need to later. But essentially, this is going to be promoted to one of the individual contexts. So we'll see. Once we reboot, this is going to take a minute here. And again, note in this case we're running version 8.6 on this box. Okay, so next, once the box is reloaded, if we look at the show mode, now we're in multiple context mode. If we look at the show firewall, notice that it maintained our transparent state when we went from single context into multiple context mode. Now this means that all user context that we define, which I'll explain in a little bit exactly what that means, the user context. In this particular version, all of the user context will have to be in transparent mode, because not until version 9 are you allowed to have mixed mode between routed and transparent. So right now, if we look at the show run, and what we're looking for here specifically is what are the different contexts that we have created. Okay, right now we have one that is called admin, and admin has been allocated two different interfaces. It has interface gig01, interface gig02, and then when we actually go to save the config, it's going to be stored in this file on Flash. Essentially, what the admin context is used for is for when you want remote access to the box, either through SSH, Telnet, or the ASDM, and you want to be able to have super user control over all of the virtual firewalls that you're defining. Because not only can this be for separation of policy, but it can also be used for multi-tenancy, where you're selling a virtual firewall as a service to a customer, in which case you want to make sure the customer 1's not able to log into customer 2's firewall, but at the same time you need some sort of overall super user login that's able to control all of them at the same time. So basically the admin context is when you don't want to have to connect to the console, but you still need to be able to move between all the different virtual firewalls or the contexts. So next thing that we're going to do is to define our different contexts. We're going to say we have context and we give it a name. We'll say we have, actually I'm going to change, let's change the firewall mode to not transparent first. No firewall transparent. Okay, so we're going to define a context and we'll give it a name. We'll say context 1. And we identify the admin context first. Let's say context admin. Admin context is admin. Okay, had I done this in the other order, if I had changed the firewall mode first and then rebooted, I would not need to do this step. But I need to say context admin config URL Okay, so in defining the context, the name is simply context 1. And then we mainly specify what are the particular interfaces that are going to belong to this context. So you can think of this like in the terms of Nexus, this would be like a virtual device context. Or in the case of the routers, you can think of this kind of like virtual routing and forwarding instances, or VRFs, where traffic from one context is not going to be able to talk to another one unless it goes to an external device and then it comes back in. So assuming that we don't have any other devices that are routing back and forth, it basically means that there's a logical separation between router 1 and anything connected behind that, and likewise router 3. So unless traffic goes out to router 2 and then it routes back in, normally we would not be able to send any traffic between router 1 and router 3. So again, either for separation of managed services like for customers, or for separation of filtering policies is typically why we want to do the virtual firewalls. So in this case, we're going to say that context 1 is going to have 2 different interfaces. It's going to have interface gig01 and gig02. So we're going to say we want to allocate an interface. Allocate an interface, we're allocating gig01, and we're allocating the interface gig02. And we need to specify where we're going to save the config. So we give it a config URL. And we'll call this just the name, context1.config. And we'll do the same thing with the other context. So let's say show run context. We're going to have context2 is allocating interface gig02 and gig03. So this link here is essentially going to be shared between both of them, interface gig02. But from a configuration point of view, assuming that we're in a routed mode, there's going to be an IP address that's assigned to it under context 1, and there's going to be a separate IP address that's assigned to it under context 2. They'll both be in the same subnet, but we'll see from a functionality point of view, normally you're not going to be able to route traffic from one context to another. Now you technically can if you configure it that way, but normally the desired design is not to be able to do that, and that's going to be the default behavior. Okay, then we say, what is the file name going to be? We'll call this context2.config. Okay, and we'll say our host name is ASA3. Okay, if we then look at the show IP, actually the syntax of the show commands is going to change. I would need to say here show Let's just say show interfaces in this case. Now, when we're dealing with multiple context mode, essentially what happens is that we have a separation between the admin context and the user context. User context is where the actual data traffic is going to flow. So this is going to be where router 1's port is assigned, where router 3's port is assigned. Those are in two different user contexts. We also have the system and we have the admin context. Those are the ones that are used for managing the box. So this means that from the admin context point of view, that's where you would SSH into, that's where you would hit the web interface with the ASDM in order to make changes to the box as a whole. Now, if we look at here from the system context and look at the show run, what changes when you're moving between single and multiple context mode is that certain commands that you used to be able to reference are no longer able to be used in the system context. They now only belong to the user contexts. So for example, I was trying to look at the show IP, but in this case it said that's not a valid command. The reason why is that you would no longer configure an IP address in the system context. We would configure it in the user context. So it's a separation of what are attributes that belong to the physical box and then what are attributes that belong to the virtual firewalls. IP addressing would be a function of the virtual firewall, not of the physical box anymore. So in order to actually manage these, we're going to say change to, and then whatever the context name is. So change to context 1. Okay, we can see from the prompt now, it shows you what particular context you're managing. If we look at the show IP or look at the show interfaces, it now is only going to give us access to the particular links that we allocated to that individual user context. So if we look at the show run, essentially from this virtual firewall's point of view, they think that the only interfaces that are available are interface gig01 and interface gig02. Now again, in this case, I'm doing this based on physical interfaces, but these also could be logical VLAN subinterfaces. So you might have one interface that's trunking on the outside, one that's trunking on the inside, and then you could do multiple logical, you could break it up into multiple logical segments by assigning the different VLAN subinterfaces to different contexts. So the end result is going to be the same. It's just whether you're configuring it on the physical link or whether you're using the VLAN tag on the subinterface to figure out how you want to route the traffic. Okay, so here in context 1, we're going to have the network on the inside is going to be the 10 network. So 10.0.0.0/24. On context 2, we're going to have the 30 network. And then on the outside, we have the 20 network. So 20.0.0.0/24. So ASA3 is going to say on context 1, on interface gig01, the name of this interface is going to be the inside. Which again, the specific keyword inside means it has a security level of 100, which is going to be the most trusted. When we go through the stateful inspection, we're going to allow traffic to go from the high security level to low and then return. Any other keyword that we use again here is going to be assigned security level 0 by default. Only the keyword inside has special meaning for this. Okay, we'll give it an IP address, 10.0.0.254/24. And then the same on the outside. Gig02, we'll say the name if is the outside, which we can see as security level 0, and we give it an IP. 20.0.0, we'll say 101 here. Okay, if we look at the show IP, have our addresses assigned, and let's see if we can ping to router 1. No, route to the host. I believe the interface, I think the physical interfaces are down. Now, if we look at the show interface, gig01, it says the interface is down, the line protocol is down. If we show run on interface gig01, the user context has certain properties that it can no longer control. Like from the system context, is the interface shut down or not? So if I say no shutdown here, it's not going to affect the physical function of the box, which is the one that's controlled from the system context. So in order to do that, what I'm going to need to say is to change to the system context. Then from here, I can say no shutdown on the physical link. Okay, if we go back to that user context, we're going to say change to context 1. Change to context 1. And show IP. Okay, let's say show IP route, or show route. Okay, now that link is up, let's ping 10.0.0.1. Okay, so basic connectivity is working. If we change to system, I believe the other interfaces are shut down as well. So interface gig02 and gig03, we're going to say no shutdown. We'll change to context 1. And let's see if we can reach the device on the outside, which is 20.0.0.2. And actually, router 2, I think, still has... Okay, router 2 has the wrong address. Let's say that this box is 20.0.0.2. Because now we're routing, we're no longer bridging between those interfaces. Okay, so in context 1, we can reach both the inside and we can reach the outside. Okay, next in context 2, we're going to do the same thing, but that's going to be for the link that's going down to router 3. So we're going to first change to the system context, then change to context 2 is the name. If we show run again here, the only thing that we should see is those two interfaces that we allocated, which are gig02 and gig03. And we're now going to specify that interface gig03 is the name if inside, which again is security level 100. We'll give it an IP address. And gig02 is going to be the name if outside. Now again, interface gig02 is being shared between multiple contexts at the same time, which means that they're going to need to have unique IP addresses, but that are in the same subnet for that particular shared interface. So on one context, we had 20.0.0.101. On another context, we have 20.0.0.102. But it's essentially both being assigned to the ASA, but it's under different logical routing tables. Now, when we look at a traffic forwarding point of view, if we were to ping 30.0.0.3, let's make sure the inside interface is working, and then we ping to 20.0.0.2 on the outside, there's a very important point that you need to take into account here. If you are doing virtual firewalls and you are also sharing the same interface between multiple contexts, is when the firewall routes the traffic out and it goes to return, it needs to figure out when traffic comes in on that interface, what virtual firewall is the packet supposed to belong to. So let's say, for example, that we have a web server on the outside. And we have a client that's located on router 1. So the client wants to do web browsing. It sends the TCP SYN to the web server. The web server replies and it gets to the ASA. Now on this local segment between router 2 and the ASA's outside interface, since we're talking about doing routing, when the packet is moving between interfaces, the devices are rewriting the layer 2 header. So we're removing the Ethernet encap, we're rebuilding the frame, rebuilding it with a new source MAC address, a new destination MAC address. Now the interface here, gig02, is going to have one MAC address on the ASA that is assigned to multiple contexts. So the issue is, when the traffic returns back in, how does it know that the client is belonging to one context versus another one? And it cannot classify it based on the IP address, because the IP can be the same overlapping between multiple contexts. So you can have overlapping addresses just like you can in a VRF on a router, or just like you can a VDC on Nexus. So the issue becomes, the firewall needs some other piece of information in order to figure out, do I need to route the packet back to context 1, or do I need to route the packet back to context 2? Now there's a couple different ways that you can do this, and you can see this is documented under the section that specifically talks about the multiple context mode, which is under general operations of the CLI. And then this is going to be under high availability, multiple context mode, and then classification example, how the ASA classifies packets. It says that there's basically 3 different ways that you can get the firewall to figure out when the packet returns back in, what is the correct context that it's supposed to belong to. One is that you can use unique interfaces, which is self-explanatory. If I have interfaces 1 and 2 in one context, and interface 3 and 4 in another one, then based on how the traffic is being received on the link, I know which one it's going to route to. Okay, that's the simplest of them. The other way is that for shared interfaces, we could give separate MAC addresses to each logical instance of that interface. So in other words, in our particular case, we have context 1 and context 2. We could say that interface gig02 in context 1 has MAC address A, but in context 2, it has MAC address B. Then based on when the traffic is returning from the outside, if the destination layer 2 address is A, I know the traffic needs to go to context 1. If the destination layer 2 address is B, then I know it needs to go to context 2. But you do have to take this into account, otherwise you end up in some unpredictable results with traffic forwarding, where some clients might be able to reach the outside, other ones won't, and it's going to flap back and forth depending on what the state of the connection table is. So in order to do this, we could manually configure the MAC addresses, but there's a feature built into the system context that allows you to do this. So if we change to system, and then in global config say MAC address auto, it says for any user context interface, the ASA is just going to generate a random locally significant MAC address. So now, for example, if we were to go to router 2 and we were to ping 20.0.0.101 and 20.0.0.102 and look at the show ARP, we see that even though these IP addresses belong to that same physical link, which is gig02, they're going to have different logical MAC addresses. But the point of this is that this is not the default behavior. So if you have an overlapping interface in multiple context mode, either you need to manually give it new MAC addresses, use the MAC address auto command, or you can use the NAT translation classifier to make sure that you know exactly which IP pools belong to one context versus another. Now that solution is less common though, and the reason why is that if you use the NAT classifier, you cannot have overlapping addressing in one context versus another. So if you have the 192.168 address from one customer, same address from another one, then the ASA is not going to be able to forward the traffic. Again, either unless you have unique MAC addresses or if you have unique interfaces. Now in this particular version, which again is 8.6, I believe, 8.6. When we're running in multiple context mode, there's a bunch of limitations that we run into when we change to context 1. One of them is that we cannot run dynamic routing. So assuming that in routed mode, the firewall is going to need to know how do I route traffic from the inside to the outside and back, it means that you're going to have to do static routing. So this is not that huge of a deal. Depending on how big the network is, maybe I just have a default route pointing out, and then routes to internal addresses like RFC 1918 that points towards the inside, that you could deal with. The thing that really is kind of a killer for this feature, at least in the older versions, is that it removes all of the crypto config. So in anything that is not version 9, if you're running multiple context mode, it removes the functionality of it being a VPN termination box, which is really one of the main functionalities of ASA. So that's one of the main features, main advantages of running the newer versions, that you can run multiple context mode, but you can also run crypto at the same time. Okay, the other one, like I mentioned, is that if we say firewall mode, you cannot issue this in multiple context mode in version 8 because it cannot be mixed. That's something that belongs to the system context. In version 9, you can selectively choose, do I want to do routing or do I want to do bridging in this individual sub-context. Now when we look at, so let's let's go to the routers here and let's check their routing table. So on router 1, let's say show IP route. Okay, we have a static default route that goes to the inside interface of the ASA, so 10.0.0.254. On router 3, if we show IP route, we're going to likewise have a default route that goes to 30.0.0.254. Okay, that's the inside interface of the ASA. Then on router 2, we need to make sure that when we are routing the traffic back, that we're pointing it towards the correct context. So here we have two different logical addresses. We have address 101 and address 102. It means that when we're doing static routing, router 2 would essentially need to differentiate. If I'm going to the 10 network, which is part of context 1, I need to make sure to route that to 20.0.0.101. But if I'm going to the 30 network, which is part of context 2, I would need to route that to the different address. So again, this is one of the disadvantages of this version, is that you can't do dynamic routing, so it makes the static routing kind of complicated. Okay, so assuming this works, if we were to now telnet to router 2, we can see router 1 is able to reach it, and router 3 likewise should be able to telnet to router 2. If we go to the ASA and we look at the show connections, or the show localhost all, in a context 1, we're only going to see the information about the senders that belong to our particular interfaces. If we wanted to see what's going on in context 2, we would need to change to system, change to context 2, and show connections all. Now, from a AAA point of view, when we're thinking about users and who is authorized to run commands in one context versus another, there's two different ways that you can set up the user database. One is that you can set up the user database in the admin context, which means that those users would have control over the complete box, or you can set it up in the user context, which means that those users would only have access to that individual context. So let's say, for example, that we have a user in context 2. We'll say username Brian, password Cisco, and we'll say that we're going to enable telnet access. Okay, so telnet, who's the source address that we want to allow? We'll just say 0 for any, 0 for any mask, and then we're going to allow this on the inside. Okay, this is turning the telnet server on. We'll then say for our login authentication, AAA authentication for telnet is going to be the local database, capital local. And let's say that we go to now router 3, and we telnet to 30.0.0.254. So that's the inside interface of the ASA. So username Brian, password Cisco. We can see this lands us in context 2. Now the difference is that once I'm authenticated to this particular context, I no longer have access to the change to command, so I can only do administrative duties that are related to this individual virtual firewall. So if I were to say change to, even though I have privileged access to context 2, I don't have privileged access to the actual chassis, the physical box. This is the reason why you have the admin context, because it's for remote access management, that you want to be able to access not only the system itself, but also all of the user contexts. So this is one of the design considerations you need to think about, that if you have multiple virtual firewalls and you want to separate roles one versus another, it means you need to have different authentication servers or different authentication databases. If you point everyone to the same TACX and Radius server, it's going to defeat the purpose of it, because one user would be able to log into to all of the context based on those same credentials. So for the admin context, for example, if we look back at our physical diagram, We also have an interface here that is gig00. Okay, gig000 I'm not using right now. So I'm going to take gig00 and I'm going to put this into admin. And then I'm going to put an IP address on this switch 2 that's connected to it on F1016. So let's say on ASA 3, we're going to change to system and show run context. So we have admin, context 1, context 2. We're going to say that for admin, for context admin, we're going to allocate the interface gig00. On interface gig00, that's not shut down. Okay, now we will change to context admin. On gig00, let's say the IP address is 192.168.0.254. We'll have username Brian, password Cisco, and we'll say anybody can telnet in from the interface. I need to give the interface a name. Let's say name if inside. Okay, so they can telnet in from the inside interface. The link on the other end of this is switch 2's port 16. Let's go to switch 2, port 16. We'll say this is 192.168.0.1. And we should be able to ping 192.168.0.254. Okay, which again is the admin context of the ASA. So if we now telnet to that particular address, telnet 192.168.0.254, we're in the admin context, and if we now change to system, then we can change to context 1. So again, typically the admin context, you don't use this for forwarding of traffic. This is normally where the management interface of the box is going to be assigned. So then you would enable SSH. In this case, I enable telnet, but normally in a real design, you would use SSH, not telnet. But the point being that if someone has privileged access to the admin context, it implies that they have privileged access to all of the user contexts. So based on the number of contexts that you have, normally that's how many authentication databases that you do, or that you need. So if you had 10 customers, you need 10 AAA databases to make sure that one is kept separate from all of the other ones. Okay, there's a question, is there a way that a user can simply change to, within a user context, to change context, or do you always need to back out? So the question is, I'm in context 1. Can I simply say change to context 2? Yes, you can. So you don't necessarily have to back out. What I was doing was saying change to system. The other way to do that is just if you exit. Well, I'm connected remotely. If I was connected through the console and we exit, that gets you back to system, but it gets you out of privilege mode. Also, there's another key feature for this, that if you, from the system context, if you show run include prompt, this command controls what the prompt is before the pound sign, basically the host name. And this is especially useful if you're doing failover and you need to know, are you primary or are you secondary, because you can do this on a per context basis. Now, we'll talk about that in more detail when we look at high availability and what the difference between doing failover and clustering is. But in failover, one box is forwarding for a particular context, and the other box is sitting there doing nothing. It's just standby. So you need to make sure that when you make a change, you make the change on the active box, and then it synchronizes that change to the standby one. But the issue is that you normally don't know which is the active box, which is the standby one, unless you look for a very specific keyword when you go to global config. So what you may want to do anytime you're running failover is to change the prompt to say hostname context state. And then this tells you, assuming you're running failover, it tells you, are you the active device or are you the standby device? Where in our particular case, we're active because failover is not configured. But if we were to then change to context, let's say context 1, it tells you what the box is, what the context is, and then whether you're active or standby. Because it can get confusing, especially because all of the addressing and all of the config is the same between the active box and the standby one. So again, we will come back to that and talk about that later. But just keep this in mind. This is one of the attributes that's under the system context is the prompt for the box globally.